as I'm sure you can imagine, producing goods and services in the real world is a very complex process. We need a way to simplify all of this. We need a convenient way to summarize the production constraint, the volume of goods and services that an economy is able to produce. So to achieve this goal, economists use a tool known as a production function, and that's a concept that you may already be familiar with. Now, we've written out an equation for a generic production function here. On the left-hand side, you can see that we have a country's total output during a given period of time. On the right-hand side, we see that output is a function of two factors of production. First, we have capital, denoted by the letter K, which is the accumulation of all of our investment that we've made in the goods that help us produce other goods and services. We can think of the capital stock as including plant and equipment, what we call nowadays the brick and mortar component of the capital stock. However, the capital stock can be defined more broadly to include, for example, information technology, including computer software that aids us in the production process. Second, we have the employment of labor, L. At the most basic level, we can be thinking simply about the number of workers employed in an economy. It's possible, however, to adjust this number to account for the quality of the labor services that they provide, perhaps the result of their education. However, in this module, we'll be keeping to this most basic definition, the number of workers employed. In addition to these two factors of production, we have a term on the left that we denote with the capital letter A, which represents how efficiently or at what cost we are able to transform these factors of production into goods and services. We call this term total factor productivity. As we proceed in this module, we'll be looking much more closely into the determinants of total factor productivity. But let's talk about it just briefly. You may have already learned that total factor productivity is, to a large extent, determined by the technology that we use. Better, more advanced technology, as reflected in a higher A, means that we can transform our capital and our labor into even more goods and services that we can enjoy. But total factor productivity can also be determined by the policies that we implement, the economic structure of our country, including its governance and rules, can also be an important determinant of total factor productivity. So now we need to make some general remarks about the production function. First of all, you may remember the concept of marginal products, the extra amount that we produce if we use just one extra unit of an input, leaving everything else constant. So let's look at capital. Okay? We think about the amount that we produce if we use one extra unit of capital, holding everything else constant. Likewise, the marginal product of labor is the extra amount that we can produce if we employ just one more worker. So we're thinking of these as MPK and MPL. Both marginal products are positive. When we employ either more capital or more labor, and if everything else is held constant, we produce more output. However, both marginal products are diminishing. As you may remember, that means as we employ progressively more and more and more of either of these factors, holding everything else constant, the extra amount that we produce becomes increasingly smaller. The next thing that I want to remind you about is constant returns to scale. Now, the idea here is that if we were to increase, let's say, capital by 1% and also labor by 1%, the increase in total output would be exactly equal to 1%. You probably know that what we've done here is just multiply each of these factors by 1.01, 1.01, 1.01, and we get 1.01 times our original output. If this property, in fact, extends to any number, so we can multiply both capital and labor by any x, and we can see that output will also change by that multiple of x. This is very important because we can define our term x as 1 over labor. This is a great way that we can express everything on a per worker basis. So we're going to divide through here by L, we're going to divide through here by L, and L over L is 1. We get everything in terms of per worker, output per worker, and capital per worker. Note that labor is divided simply by itself. It's a constant, 1. So constant returns to scale help us get an expression for output on a per capita basis. This property is going to be very useful to us as we move forward and do more analytical work.